Welcome to the Crazy Hat Chemist. So today we're going to do another video on bonding and molecular structure. I can't wait. Bam! Today we're talking about the two different theories about bonding here. So number one is the valence bond theory, or VBT, or just VB for valence bond theory. And that's by Linus Pauling. Okay, he's the guy that did the electronegativity scales. Okay. The valence bond theory talks about localized electrons. Those are localized in between atoms, either bonding or lone pairs of electrons. This gives a qualitative representation or a visual representation of molecular structure. Okay, it represents very well ground state molecules. Also, hybridization is coming into this one is a correction factor for something that doesn't work out quite right, especially if we look at the number of electrons and the number of orbitals and their shape and where they can be placed. I will describe that later on. The second theory about bonding is the molecular orbital theory, or MO or MOT, and that's by Robert Mulliken. Okay, and this deals with delocalized electrons. Delocalized means they're spread out as opposed to localized in between two things. So the delocalized electrons are spread out through the entire molecule. Okay, this gives a quantitative representation of bonding. I mean, a numeric value. You have bonding regions and anti-bonding orbitals and anti-bonding orbitals. Okay, this represents higher energy or excited states of atoms. Very key there, of which the valence bond theory does not. It also works very well when you're talking about the colors of compounds. It describes the colors of compounds, how you arrive at those colors of those compounds, and it predicts paramagnetism and diamagnetism. Okay, I'm going to show you two different structures here. This one here is one particular structure. We'll talk about that a little bit later on. But hopefully you see the blue or kind of blue lines here in between the atoms. Though that's representing the valence bond theory. So those are electrons in between atoms. Those are localized in between the atoms. And then you see those kind of like purpley, kind of like dome-shaped halo things above and below. That's representing delocalized electrons, where those electrons are spread throughout the entire molecule and not localized between atoms. That's one of the major differences between the valence bond theory and the molecular orbital theory. Here's another representation of the same thing here. So you can see that ball and stick model in the middle there, where you have the gray sticks representing the localized electrons of the valence bond theory. And the molecular orbital theory is the kind of gray region that spreads throughout the molecule. So that means that the electrons are spread throughout the entire molecule. Okay, those are the two bonding theories, valence bond theory and the molecular orbital theory. We're going to be mostly discussing the valence bond theory. Okay, we won't really be getting into the molecular orbital theory, although it's super cool. We can get paramagnetism and diamagnetism by drawing orbital box diagrams without doing this theory. Okay, so just make sure that you remember that and note that down. If you can do the orbital box diagrams, you can get paramagnetism and diamagnetism, even though the molecular orbital theory will also predict it as well. It will also predict whether or not a bond is actually stable and the type of bond, either no bond, a half a bond, a single, double, or a triple bond, for example. Okay, all right, that's another Crazy Hat video by the Crazy Hat Chemist, and if this hat is a gone, I'm fishing. Have a great day. Give me a thumbs up if you feel like that video. Subscribe to my YouTube channel. I'm going to see you next time for some more cool chemistry videos. Pass on the word, baby. Bye now.